What would happen if our sun, the very star that gives us life, went head to head with the largest black hole ever discovered? This isn't just a space battle. It's a clash of cosmic titans. On one side, we have our familiar life-giving sun. On the other, a monster named TUN 618, a black hole so massive it defies imagination. Get ready, because we're about to explore a scenario that pushes the laws of physics to their absolute limit. Let's set the stage. Our sun is a pretty average star, about 865,000 miles in diameter. It's huge to us, but in the grand cosmic scheme, it's just a dwarf. Now, meet its opponent, TUN 618. This isn't just any black hole. It's an ultramassive black hole located billions of light years away. How big is it? Its mass is estimated to be 66 billion times that of our sun. That's not a typo. 66 billion. Its event horizon, the point of no return, is so vast that you could line up 11 of our solar systems, from the Sun to Neptune, and they would fit comfortably inside it. So, how does this epic showdown begin? For this to happen, we'd need to magically transport our sun across billions of light years, right to the doorstep of TUN 618. Imagine our sun, a tiny speck of light, beginning its long, final journey toward this behemoth. As it gets closer, the first thing it would feel is TUN 618's immense gravitational pull. This isn't a gentle tug. It's an inescapable cosmic force. Long before the sun even gets close to the event horizon, it would encounter the accretion disk. This is a massive, swirling disk of superheated gas, dust, and the shredded remains of other stars that got too close. This disk is brighter than entire galaxies, glowing with unimaginable energy as matter spirals inward. Our sun would plow into this cosmic blender, and the friction and radiation would be intense. The outer layers of the sun would start to heat up and get stripped away, creating a glowing tail behind it, like a comet being vaporized. The immense gravity of TUN 618 would start to deform the sun. It wouldn't be a perfect sphere anymore. The side of the sun facing the black hole would be pulled more strongly than the far side. This difference in gravitational force is called a tidal force. The sun would be stretched out, elongated into a teardrop or egg shape, a process known as spaghettification. But for an object as large as the sun, it's less about turning into a noodle and more about being torn apart piece by piece. As the sun gets closer, these tidal forces would become catastrophic. The sun would reach a point called the Roche limit, the distance at which the black hole's gravity overcomes the sun's own gravity holding it together. At this moment, the sun would be violently ripped apart. It wouldn't be a clean break. Giant streams of solar plasma, superheated gas, would be pulled from the sun, flowing like fiery rivers toward the black hole. Our star would unravel. This stolen material wouldn't fall straight in. Instead, it would join the chaotic, swirling accretion disk. As this fresh solar plasma spirals inward, it would accelerate to near the speed of light, crashing into other material. The friction would heat it to millions of degrees, causing it to emit brilliant X-rays and gamma rays. The dying glow of our sun would add to the blinding light of the accretion disk, making it even more luminous. Now, let S address a key part of the prompt: the idea that the black hole itself would go supernova. This is where we need to separate science fiction from science facts. Black holes don't go supernova. Supernova are the explosive deaths of massive stars. Black holes are what's left after some of those explosions. They are cosmic endpoints. However, the process of the sun being consumed could create one of the most spectacular light shows in the universe. The sheer amount of energy released as the sun's mass is converted into radiation in the accretion disk would be mind-boggling. It wouldn't be a supernova, but it would be a tidal disruption event, and from a distance, it would look like a brilliant, long-lasting flash, outshining galaxies for a time. So, the black hole doesn't explode, but what about our sun? In this fantastical scenario, let's imagine a twist. What if, just before being completely devoured, the intense gravitational stress and the flood of radiation from the accretion disk triggered a dramatic reaction within the sun itself? Normally, our sun is in a stable balance, with the outward pressure from nuclear fusion in its core perfectly countering the inward pull of its own gravity. But in this extreme environment, that balance is shattered. The tidal forces could compress the sun's core, dramatically increasing the rate of nuclear fusion. The sun would start burning through its hydrogen fuel at a furious, accelerated pace. It would swell up not into a normal red giant over billions of years, but into a bloated, unstable, and temporary giant in a matter of moments. This stress-induced expansion would be violent. The sun, now a distorted, swollen star, would start lashing out. It would unleash solar flares of unprecedented scale. These wouldn't be the flares we see today. Imagine flares 1,000,000 times more powerful, vast tendrils of plasma erupting from its surface, lashing out into space. These superflares would be like the dying screams of our star, a final act of defiance before its inevitable demise. Now, let's bring this catastrophe back home. What would this mean for Earth? Let's pretend Earth was somehow dragged along with the sun on this journey. From our vantage point, the sky would be a terrifying spectacle. The accretion disk of Ton 618 would fill our view, a brilliant, swirling vortex of light. As the sun expands and unleashes its fury, we'd be in the direct line of fire. A massive solar flare, larger than anything humanity has ever witnessed, would erupt from the dying sun and race toward us. These aren't just light and heat. They're a wave of charged particles and intense radiation traveling at nearly the speed of light. Our planet's magnetic field, our protective shield, would be instantly overwhelmed. It would collapse. The moment this wave of energy hit, our atmosphere would be stripped away. The side of the Earth facing the sun would be flash sterilized, scoured clean of all life. Oceans would boil away into space. The surface of the planet would be heated to molten rock. It would be an instantaneous planetary scale apocalypse. There would be no hiding, no surviving. Earth would be rendered a lifeless, charred husk in a matter of minutes. Back at the main event, the sun's final moments are playing out. The swollen, flaring star is now just a stream of plasma feeding the monster. The core of the sun, the last remnant, would be pulled in. As it crosses the event horizon from our outside perspective, it would seem to freeze in time, its light redshifting into nothingness. For the sun itself, its journey would end in the singularity, a point of infinite density where our understanding of physics breaks down. The sun would be gone, its mass added to the incomprehensible bulk of ton 618. So, the sun fights the largest black hole. Does it win? Absolutely not. It's not a fight. It's an execution. It's like a single drop of rain trying to fight the ocean. The sheer difference in scale is too immense. The sun is torn apart, consumed, and its energy is added to the black hole's brilliant, deadly halo. And Earth, a silent witness, is vaporized in the cosmic crossfire. It's a humbling thought. Our entire world, our history, our future, all exist thanks to the stability of our star. But in the grand, violent universe, even stars are fragile. This scenario, while fictional, is a powerful reminder of the immense forces at play in the cosmos. It highlights the raw, untamable power of gravity and the sheer scale of objects like ton 618, which make our corner of the universe seem incredibly small and precious. It's a universe of breathtaking beauty, but also of terrifying power. Thank you so much for joining me on this cosmic journey into destruction. It's a wild thought experiment, isn't it? If you enjoy exploring these mind-bending what-if scenarios, make sure to hit that like button and subscribe for more adventures into the vast, mysterious universe. Let me know in the comments what cosmic battle you'd like to see next. Until then, keep looking up.